Hello, everyone, and welcome. My name is John Brennan with MathWorks, and thank you for joining our webinar, Developing, Verifying, and Validating IEC 62304 Compliant Code with MATLAB. So in it, we'll review how you can optimize and improve your MATLAB-based development workflow using the newly released MATLAB Test product, along with some related products. Now, I am joined today by Oscar Molina. Oscar, say hello.
Hello everyone.
Oscar is our application engineer based out of our Plano, Texas office, and he'll be providing the demonstration today. So a few logistics before we get started. First, if you encounter any technical issues, audio challenges, please feel free to post them in the chat. We'll do what we can to help you troubleshoot. Also, if you have questions for our presenters, myself, we encourage you to use the Q&A session or section of the side on your screen. This will allow us to respond directly to you and answer as much as we can during the session. If we can't, we'll follow up with you afterwards. A link to the recording from today will be emailed to you within a few days, so you will get this recording. So let's start with a level set. This talk is centered around embedded software for medical devices per the IEC 62304. But the concepts that we're talking about, they can be applied to other medical standards, such as software as a medical device, or even other regulated industries. So it has a relatively broad applicability. I'm going to show this agenda slide here. So we have a very simple 4-part agenda for the next 45, 50 minutes or so. We'll present this new V&V workflow for IEC 62304. We will then introduce MATLAB Test. Oscar will follow up showing a demonstration of the tools and actions, highlighting some of the key new features that enable verification and validation for IEC 62304. So let me start with a study from Wilson Research, which shows that from specification through to testing, where bugs are introduced and where they are detected. Now, we see most bugs are introduced at the spec level, and this is due to incomplete requirements, changing requirements, poorly documented requirements. But the majority of those bugs, they're actually not detected until after the design implementation, until the test phase. And this is pretty late in the design cycle. If we layer on top of this study, the workflow from many of you today, we see that MATLAB is used for prototyping to effectively prove the algorithm. But then the design team takes it from there to redesign the algorithm in C, and then eventually apply testing to that algorithm. So what's the cost of doing that is effectively late stage bugs. And we know through many industry studies that the cost per bug increases significantly during the development process, meaning the later you test, the more expensive it is to fix. So the question we need to ask ourselves is, how can we make this flow better and find bugs earlier so we can reduce the overall development costs? So let's take a look at this. So to start, let's look a bit deeper into the traditional workflow and what improvements we could propose. So the gap, the red box at the top, shows this discontinuous workflow from MATLAB to C. Now let's see the impact of that at a high level. So per the previous slide, because test is done at the end, the cost per bug will be very high. Next, we see redundant work is the design's actually coded twice, once in MATLAB and once in C. Another area of redundancy that we see in this flow is that requirements have to be internalized and recorded and documented twice, once for the MATLAB side, once for C. Good place for human errors to be introduced. Now, if we are able to code connect the MATLAB flow to the C flow, there may be compelling improvements that we can suggest. Here is what we can do now that we have MATLAB Test. It starts with acknowledging that the algorithm is the design. Why code it twice? This enables us to do shift left testing and apply rigorous and systematic testing earlier, as well as we can trace requirements through the entire workflow, even into the generated code. Last, we have the opportunity to use automatic code generation. So it's this combination of the green boxes that are clear and compelling value drivers for change. And I want to take the opportunity to explain a little more about this. So you may be questioning automatic code generation naturally, but it is a proven and trusted process with lots of value. Look at the story from Renault. So we see the manual coding effort in blue and the automated process in red. The green line represents the productivity gains across 10 projects. Now, in all cases, there's improvement. And on average, there's a productivity gain of 59%, pretty significant. Automatic code generation is a trusted process for virtually all industries, but it is fairly new in the medical device field. Now, as a point of reference, one of the most stringent certification standards, the ISO 26262, think self-driving cars, they've been using MathWorks automatic code generation tools for years. And specific to medical, look at this quote from IDNIO. MATLAB and embedded coder enable us to reduce the time we needed to complete the project from 24 months to 12 months without adding additional engineers to the team. Now, this is a documented story that you can find on our website. So there is compelling evidence that automatic code generation works. Maybe we should give it a try. Let's transition now to the tools that make all of this happen. So we're going to talk about MATLAB Test at a high level. Oscar will show you the details. But MATLAB Test is the enabler for the shift-left verification approach by reducing the risk of software failures with comprehensive and systematic testing. MATLAB Test increases rigor by providing advanced coverage capabilities, showing you gaps that you just can't see today with normal coverage. And it enables requirements-based testing with traceability through the entire workflow and provides equivalence testing between MATLAB and the generated code. This provides systematic assurance of code quality. Now, the net result is that it streamlines verification flows. Each of the capabilities we just discussed creates metrics. Those metrics get aggregated into a dashboard, which we'll show you, and this provides clear measurement and progress of code quality. The dashboard's interactive, the results are persistent, hence you're providing even greater productivity. What's the value of all this capability? Well, adoption and implementation of testing rigor provides a 10x return on investment compared to manual and ad hoc efforts. This, according to one of our customers. But even if you don't adopt the entire workflow that we're going to be talking about today, just having some levels of testing and even better systematic testing offers a clear ROI on your coding practices. So MATLAB Test incorporates the features needed to support the capabilities we previously described, but it works in conjunction with the rest of the MATLAB platform. So base MATLAB offers many of the utilities and capabilities that you'll need, such as the unit test framework and the new test browser, to name a few. This slide represents the complete ecosystem of capabilities needed for certification workflows. And I'll be highlighting how some of these tools are used in the next few slides, so I won't go into it at this stage. The heart of the workflow, the hub of your verification, starts with the quality dashboard. This is the most stunning and visual feature of our new MATLAB Test toolbox. And this really represents the interaction of what you want to do and how you want to do it. So we're going to start with requirements, because requirements are the most important things to get right. And we have a toolbox called Requirements Toolbox. Like your code, it will change, it'll get updated, it'll become more verbose throughout the development process, but that's to be expected. The idea with Requirements Toolbox is that it is alive and it stays active during the entire development process. And by linking requirements directly to the code and directly to the tests, you get a roadmap of what needs to be done and to what extent. Now that we have a design, the next thing we want to do is analyze that code, and we have a new code analyzer set of capabilities for doing just that. Once you get that stable code base, what you want to see is, well, what code issues do I see? And when you click on the dashboard, it brings you directly to the code analyzer. And code analyzer will help you fix those code issues, as well as to identify other areas that need to be improved. From there, the next thing you'll be doing is creating tests, utilizing our unit test framework, and then managing your test suite from the test manager within MATLAB Test. Finally, your code coverage metrics also are aggregated into the quality dashboard. These are HTML reports, which are interactive and clickable. They help you find holes in your testing suite by identifying gaps which could lead to unintended functionality. Equivalence testing is used once your code base is stable and you're ready to transform your application to another language. Equivalence testing ensures integrity of the transformation process. MATLAB Test supports .NET, Java, and Python through MATLAB Compiler SDK. And we support C, C++ transformation with MATLAB Coder. One really nice feature of this end-to-end workflow that we're talking about today is that once the code is transformed, the requirements stay with that transformed code. So you can see the requirements even in the generated code, which really is useful for ensuring traceability of the code from the very beginning all the way through the very end. And in addition, the code coverage associated to the C code can also be visualized and viewed through those HTML reports within MATLAB Test. So now that we've completed our requirements-based testing, we're ready for certification, and here's how we can help. The FDA wants you to provide objective evidence that your process is safe and effective. And obviously this must include the tool chain that you are using. Tool qualification is the notion of pre-qualifying tools to specific industry standards. MathWorks now supports tool pre-qualification through to the IEC 62304, and this includes now MATLAB, MATLAB Test, and Embedded Coder, which are all certifiable from a tools perspective. So this is great news because if you've ever done it, it's a lot of work to get the tool qualification done and done right. So this is going to save you weeks and months of documentation that you would normally have to do yourself. As the graphic on the right suggests, you are still responsible for providing objective evidence that the application works correctly, but everything needed from the tool side is all pre-qualified through the TUV, and those certificates are available for you to reuse. So let me summarize my section on this slide. So we're looking at the end-to-end contiguous workflow certification supported by MATLAB Test. So this solution provides traceability to connected requirements throughout the workflow. It enables shift left systematic testing, provides productivity improvements with automatic code generation, and saves you time by having to code the design only once. This contiguous workflow is enablement for dramatic productivity improvements. So even if you don't use our automatic code generation technology, there's still compelling 10x ROI opportunity by adopting systematic testing into your algorithm. Now on the bottom, you'll see the list of tools that is utilized within this workflow that we're talking about. And it's a combination of requirements toolbox, MATLAB and MATLAB Test, typically MATLAB Coder and Embedded Coder, as well as the IEC certification kit. So this new workflow, it enables these optimizations and offers compelling value to consider changing the way you're doing things to something that is code connected, as we've talked about here today. Now, enough talk about what it is from a slide perspective. I think it's time to transition to what it looks like within MATLAB. And so for that, we're going to shift over to a demonstration. And this demonstration is going to be done by Oscar, and we'll be demoing effectively a medical demo. So this is an ECG classification application. This is using pre-trained CNN kind of learning for classifying patients' ECG information, things like normal sinus rhythm, arrhythmia, congestive heart failure. The heart rate and the breath rate are calculated by the application itself using wave decomposition and reconstruction techniques. So the role that MATLAB Test plays in this particular application is that it manages the various test suites and links to the requirements. It runs those multiple unit test suites with MATLAB Test. It generates code coverage and code quality reports, and it provides equivalence testing on the MATLAB generated C, C++ code. So with that, Oscar, I'm going to flip this over to you for you to walk us through what this actually looks like in practice.
Absolutely, John. Thank you so much for the introduction. And simply put, what I'm going to do, please let me know if you see my screen. John, can you see my screen okay?
Not yet.
Not yet? Okay, let's see. Give me just 1 second. How about now?
Yes, we're good.
Awesome, awesome. Right, so hello everyone. What we're gonna do in the next few minutes is to put all of the concepts that John was describing into context and into practice actually. So John mentioned that for that objective, we're gonna be using this application. And it seems a little bit too complex because it has so many moving parts. So let me first break them down for you to see what's happening with this application. So what you see here is the ECG signal plot or the ECG signal data for a given patient, right? So we took the data for 35 or 30 something seconds, and then we're making some inferences or calculations based on that signal. The first thing that we're doing here is we are using deep learning network to try to understand whether or not the patient has a heart condition that needs a doctor's or physician's attention, right? So something might be happening, and then this deep learning network will help us understand what is that, right? So that the doctor can take the proper action. So the other two things, let me highlight them over here. First, we take the same signal and then we calculate or estimate at least the heart rate of this given patient, right? So there's a bunch of wavelet decomposition and signal processing analysis that we're using under the hood in order to make this calculation possible. And the same is true for the breath rate calculation that you see down here, right? Excuse me, that you see right here. So there are pretty complex algorithms working under the hood for this application. But really, when we think about the app, because this is an actual app, there are many more parts or moving parts to it, right? Like even if we think about this light bulb over here, right? Or we think about this icon, or even if we think about the patient information box, there are some things that we need to pay attention to and treat accordingly when we are developing this software, right? And I'm going to show you what that is step by step and how MATLAB Test fits into the picture of maintaining such a complex software application. So the one thing that John mentioned is that we have our command center that we call what we call the code quality dashboard, which is right here, where we can see that MATLAB is already giving us some hints about the health of our code, right? Like everything that is related to this application is right here. So we see some coverage, code coverage for this specific application. We're going to walk you through all of each of these in just a minute, but we also see what is the status of my unit testing and what's my status of my testing and code being linked to the requirements. In other words, the code quality dashboard will give you a snapshot of the status of your application so that you or a software development manager can see what is exactly going on with a specific software product. Okay. So the first thing that I want to show you is the requirements editor. So as you may know or be aware of, MATLAB has a requirements toolbox in which you can specify each of the requirements for your specific application. So for example, right here, I have different groups with specific requirements for each of them, right? So for example, first one or the first section is going to be about the patient's data, right? We talk about this tiny box, the patient information data that we have here on the screen. And notice that there are different requirements to it, right? And there are some links down here that are showing me which piece of the code is actually implementing that requirement and which piece of the unit tests are actually verifying that requirement. So I'm going to show you how that works in just a couple of minutes, right? So first, let me go and show you what the patient function is about. So here's the function. It's just a regular MATLAB function that takes some inputs like the patient's first name, last name, age, some patient ID signal, which in this case is going to be the ECG signal plus the frequency of it, right? And don't worry too much about these assertions right here. Suffice it to say that what we're doing is we're making sure that all of these inputs that we are providing to this function are actually valid, right? So think about, in first name, for example. So first name must be alphanumeric alphabetic string, right? We cannot accept non-alphabetic characters. When you think about the age, it cannot be less than 0, right? Or it cannot be greater than, hopefully, 120. And the same is true with the ECG signal and the frequency. So there are some tests that we need to perform in order to make sure that this function is going to work as expected every single time, right? And for that matter, I'm using assertions like, this is a light way for me to shield my function for it not to do something that hasn't been intended to do, right? So I'm using a bunch of assertions. And then next step is, how do we test those assertions, right? So that's going to be the first step. Now, notice that I have some like yellow highlighted lines right here, right? For example, here in the patients, we have this first line, and then we have this line 16 through 28. And if we go back to requirements, and then we see that actually this is showing us that there's a link between the patient function and then the actual requirements, right? So here we see that the line that says function P equals patient and the input arguments is actually implementing that requirement, whereas we have a class that, as I said, we're going to show you in just 1 minute, is implementing all of the unit tests for this class, right? Or for this function, actually, right? What is the easiest way we have to test this patient, right? So I came up with this. I mean, you can also come up with your own ways of testing this using a script. That's the simplest way by which we can test this function, right? So I have some common variables. I really don't care much about the signal or the age or the ID because I'm really not testing it at the moment. I want to test my first and last names, right? How my function is actually showing me that there's some errors going on. So I created different sections with this script, as you can see right here. And in the end, at the end of it, I will just clear out the variables that I created at the beginning of this unit test suite, right? So first test should pass, right? Because I'm not doing anything strange right here. I'm just using my first and last names as character arrays, so they should be fine. Whereas line 2 or test 2 actually, test 4 should fail, right? Because for once this one is a number, so an integer actually, so it shouldn't be allowed. And then right here we have non-alphabetic characters which shouldn't be allowed either. So what happens if we run this? So if we run this script, it errors out, right? And it's telling us, hey, line 16, something happened. We couldn't get there because something happened at line 8, which was expected, right? We were just talking about it. This test shouldn't pass. Now, the question is this a good way of testing your algorithms? Perhaps not, right? A couple of reasons why. Let me tell you one. Notice that the script stopped at this point, right? We didn't get to test these 2, so henceforth we didn't get to get to the end of the test. And for second, we didn't get to clear up our memory. So there's a bunch of data still in memory that we need to take care of, right? Now, we can do this in a better way, right? And what we can do is actually use what we call a class-based unit testing, or creating a unit testing suite using a class-based approach. Now, how do you do this? Let me just show you kind of like back to back what that means, right? So first of all, if you want to create a class-based unit test suite, you can come here to the new option, and then see that here you have this test class option. So when you do that, MATLAB will give you, actually let me do it so that you can see what's happening here. So MATLAB gives you the structure of a class-based unit test, right? So here is where you set up your your parameters, your variables, and down here where you see the methods test is where you are actually defining the test. So the same way I did here with a like sections on script, I'm doing here with different functions or unit tests, right? So there are a couple of changes right here because I have to convert these into functions. So there are a couple of commands that I need to use in order to make that possible, right? But once I put it this way, I also have this facility right here, because now MATLAB understands that this is a unit test suite, and then gives me the options to run them directly. So notice that I can just go ahead and run these tests. And then to the right, you can see that my tests are all running and they all pass because I specify that my fourth test should fail, right? Let me just highlight it again. Once again, here I know that my test 1 is going to be warning free. My test 3 is going to be warning free, but my test 2 and 4 should error out, right? So MATLAB was able to catch all of these conditions and they all passed. What you're seeing right here to the right is what John mentioned just a couple of minutes ago. This is the MATLAB test browser, right? So here's where you can import your unit test. I mean, if you have more tests, you can just import them and run all of the tests right here, and then get some coverage report, okay? So here, you can actually specify that you want to get some coverage for your test, and then add the source code to it, and then see what's the outcome. So for example, if I wanted to add, I don't know, the file, in this case, I'm testing patient, right? So that's the function I'm testing. Let me just add it up right here, and then rerun the test once again. Now that I run the test, MATLAB will give me what we call a code coverage report, in which, I'm seeing, oh, yeah, I got to run this function and it ran flawlessly. The function was fully covered, so no issues there whatsoever, right? So you have that view right up front by just running this test and enabling code coverage, right? Now, imagine having to do this with each one of your unit tests in your software units in your program. So for example, right here, I would have to do this manually with every single piece of my software. So this can become cumbersome very quickly, right? So the question there is, can we do better than this, right? How can we put all of these tests together in one place that I can manage right at once, and be aware of which tests are failing, which tests are passing, and get the code coverage report, not just for one single test, but for the entire test suite. And this is where MATLAB Test comes into the picture, right? So let me go back to the code quality dashboard. And as John mentioned, so you can essentially come here and click on this dial, on the test dial that you see right here on the right-hand side of my screen. Or if you have your MATLAB project, you can look at this option in your tools menu, right? So here you have the MATLAB test, okay? So if we open it up, we will have, I already run this test prior to this webinar so that we could, get to see the results up front. But there are many options with this MATLAB Test Manager. It's very useful, actually. So for once, here you can see all of the unit tests that I prepared for this particular application. And you see that most of them, or almost half of them, passed but some of them failed. It doesn't mean that the entire test would fail, but there are some tests in particular which failed, right? So for example, let's focus on this patient 38 that failed, right? So here MATLAB is telling us, yeah, here you can find some more information about what happened with this particular specific unit test. If we open it up, we see that something went wrong because I was expecting some value and I got a -1, meaning that the actual function failed, right? And this is a heart rate calculation. And remember that I mentioned that heart rate is based on some way the composition and reconstruction analysis. So it's a pretty complex function. So it did fail. And then we're going to find out in just a minute what happened there. Another advantage is that you can filter right here. You can use a filter and then say, for example, heart rate, and then the MATLAB Test Manager is going to show you all of the tests related to that specific function. Plus, if you right-click here, just give me 1 second. Actually, if you come here to this side to configure columns option, you can also add the tags option and the test requirements options. And then you are linking requirements with your code and unit tests right up front, right? So this is going to be very useful for you, especially those of you who are doing requirements-based testing, right? Because you need to keep track of which unit tests are testing which requirement, right? So right here, you can see that this test has some tags and also it has some requirements, right? So this is all linked. So you can simply click over there and then MATLAB Test will automatically take you to that specific requirement. Couple more things to notice before we get into patient 38 right here. Actually, we can do it right now. So if we think about this data, is like, you might think, okay, what went wrong? Is it the algorithm? Is it the data? Did I hit an edge case? What really happened there? So here I'm going to show you what happened with patient 38. So let me just clear my screen very quickly and then run this function. So I just created this function myself just to plot the ECG signal data and see what's going on with this patient 38. So we look at the plot, and then maybe I did not mention this at the beginning, but part of the secret sauce of these algorithms is to read all of these peaks and do some sort of normalization in order to estimate the heart rate and the breath rate, right? But to do that, we need a minimum number of peaks in order for the calculation to be accurate. But then look at what happened here. So half of the signal has some, like min-max level or approximately the same min-max level, but the other half of it went all over the board, right? So what the function, the algorithm is reading is this part of the signal, the right-hand side part of the signal. Therefore, it errored out because it didn't have enough data for it to make a conclusion about both the breath rate and the heart rate. So this is actually telling us that we also need to be very careful with the data that we put or pass through these algorithms, and MATLAB Test is upfront, like really very quickly helping us to detect this type of potential errors when it comes to application deployment. So going back to MATLAB Test, another couple of features that I wanted to highlight right here are the code coverage option that I just showed you just a couple of minutes ago with the MATLAB Test browser. Here, you can decide what level of code coverage you want to see for the entire unit test, right? Like right here, you have statement coverage, decision coverage, condition coverage, or modify condition decision coverage. And you can see that I just wanted to go all the way up, to the most stringent code coverage metric, which is MCDC, and see what happens there. So now, also, I show you about the code coverage metrics right here. So you have them right here on your code on the code quality dashboard. So you can simply click there, or you can come here to MATLAB Test Manager and then click over this option, which is, it shows you the latest coverage report, and then it will show you that the big summary of all of the functions involved with your application. And you can see right here that we are using 8 such functions, right? Let's take a look at what this is telling us up front. First, you see that here the coverage metrics are broken down by, by metric itself, by the metrics itself, right? Be them function, statement, decision, condition, or MCDC. Let's take a look at this is alpha function. I mean, I'm curious about it because the code coverage, functional code coverage is 50%, and it's kind of eerie because it's just a function. So if you call it, you should be calling it entirely right. You're not calling half a function. So let's take a look at what happened there. So again, remember that we are going to be looking at function coverage. So to do that, we come to this drop down, and then we pick the function coverage, and then we pick the function we want to analyze. So MATLAB Test is going to show us what is happening with this function. And notice that this function is alpha function is being called or was called 400 times, right? So we have it there as green. But on the other hand, we have the is not alpha function that was never called, but it's right here, right? So MATLAB will highlight it in red, just telling you that something is happening with this function. So there might be a couple of ways to look at it. One is, oh, maybe you don't need the is not alpha function given that you have the is alpha function, right? So it's like, I never got to call it, so maybe, I don't know, maybe I don't need it. That's one way to look at it. Second way, or another way would be, if this function is there, it's probably because there's some requirement that asked me to create this function, right? Therefore, if it wasn't test at all, I need to create some unit test to test that is not alpha function, right? So, and that call will be made by you who are developing this software, right? So you are the one who knows best. However, if you have a, excuse me about that, but if you have the requirements, you exactly know what to hit, where to look at it, right? Jim, do you mind taking a look at the questions in the chat box? Maybe you can help John with that. All right, so this is just functional coverage. And again, it's a great tool that we have here with MATLAB Test that we can look at the coverage metrics right away, right? But let's take a look at the more complex coverage metrics. So for example, decision coverage. So we see that the ECG classify function has 80% coverage. Is that any good? Is that enough? Let's find out. So let's highlight this function and take a look at what MATLAB has to say about it. So for once, we see that there are 2 lines right here that were highlighted like in gold type of or orange color there. And it says that, well, MATLAB actually hit that line of code, but every single time it always returned a false statement, meaning that you never got to get inside of this statement. So the decision was always just move on. Now let's take a look at what's happening here. So the code is saying, right here, if I have a GPU on my computer, then use it to execute my deep learning network classification algorithm, right? Else, if I have my parallel computing toolbox running, then execute this in parallel. But I have neither of them active, nor I have a GPU, nor I have the parallel computing toolbox up and running. So 2 things can come to mind right there. One is, okay, maybe I can get away by just running it in serial. Maybe it's not that big of a deal for this seemingly lightweight application, but you don't know how well will it scale up, right, in the future. The other part is like, perhaps I can test this on an actually powerful computer that has not only one GPU, but perhaps multiple GPUs and multiple cores, and I can test this algorithm with not only hundreds of patients that I have right here, but thousands of them, right? So we can start thinking about CI pipelines, testing in the cloud using the same workflow. So all of that we can see just by looking at the code coverage report. Another thing to mention right here is that John mentioned about equivalence testing, right? And equivalence testing is when we take this code. Actually, let me open up one of one of these tests, maybe the breath rate test. That could be a good one to look at. And then let me open up the equivalence version, the equivalence testing version of it, and then I'll walk you through what that means for equivalence versus MATLAB testing. Okay. So the first thing is, when we think about unit testing in MATLAB, MATLAB will rely on the superclass in which John mentioned at the beginning, which was the MATLAB unit testing framework. So this is where you can unleash actually the full power of the unit testing framework with class-based testing. This is why we recommend you doing it this way, right? So then you have the constructs, and then you have the tests, plus you have something that I wanted to highlight, which is test tags. Test tags will allow you to put a tag on your tests so that when you come back to your test manager, you can actually run customized test suites, right? So here you have the manage custom test suites option. And with that, you can specify, for example, here I have this test suite, which will call or will bring in any test that has this PIL test tag, right? So this is what I'm doing right there. All right, so this is in a sense how you construct these unit tests with a class-based approach in MATLAB to be tested with MATLAB test, right? But on the other hand, if we want to test this with equivalence testing, meaning that, all right, I have this function in MATLAB, but really my goal is to deploy this to an embedded device, right? I need to write this code in a more embedded device friendly language like C, C++, right? How do we do that? But most importantly, how do we make sure that the code that we are going to create is actually delivering the same results or the same output, at least close to numerical accuracy to those that I get from MATLAB? And this is the whole purpose of equivalence testing. So notice that here I'm using the unit test superclass. Here I'm using the coder superclass. And as John mentioned, this is when we are going to be using MATLAB coder and embedded coder toolboxes, right? Because those are the toolboxes that will facilitate performing those tests. Once we, like the first step in creating this test class is to define what kind of code we want to generate. In this case, I'm going to generate the static library for this particular function. And then, I use some random numbers just to tell MATLAB what type of variables do I have there as input, right? For the data type conversion, so that MATLAB can take care of that by itself. Then I have some parameters, and here's where I have the meat or the core of this topic, which is executing my test, but as a C code or as a static library with these inputs, right? So I execute the test for these many patients that are linked to some ECG data. But then what's important to notice is that down here is where I actually verify that the execution of that C code, that static library, actually matches the data of the MATLAB algorithm down to an absolute tolerance, right? So I'm specifying, what, I'm good if the tolerance or the absolute difference between the outputs is less than equal or less than 10 to the minus 6. It might be too stringent for you. It might be too loose for you. It is for you to ultimately decide which will be a really good tolerance for you to accept that conversion from MATLAB code to C code. And again, to emphasize on what John told at the beginning, this is where we have the left shift type of approach where your algorithm becomes actually the model, right? So everything will center around making sure that the results that you're getting from the generated code are actually matching that from the MATLAB design, right? So you can run all the unit tests right away, right up front, and rest assured that the C code that was generated with MATLAB is actually, up to the required standard. A couple more things to note here is that see that right here I also have the options to run these tests directly from my script editor, because MATLAB understands that this is also, even though it's an equivalent test, testing suite is still a testing suite, so MATLAB will allow you to run the tests using these shortcuts. I won't do that right now just for the sake of time, but it will take like 5 minutes. And in the end, you can generate a report, a code coverage report, similar to the one that we just saw, in which MATLAB will tell you, hey, this is how the function went, and these are the lines that you hit with your unit tests, and so forth. So that it's also possible. Not only that, John mentioned that we can do the same with Java files or Java generated files, or with Python generated libraries that we create with MATLAB Compiler SDK. So we really have a really great solution with our coder and compiler tools. Not only that, but also you can actually test this algorithm in an actual embedded device. And this is what we call processor in the loop. So notice that, perhaps right here, this is where I'm still using the coder superclass, meaning that I'm calling the MATLAB coder toolbox in order to perform these tests. And you know what? Actually, perhaps this is a better way to look at these two files. So I'm still going to be using the breadth rate equivalence testing in order to show what's the difference between software in the loop, meaning generating code and testing it locally on your CPU, and processor in the loop, meaning deploying the code on the actual embedded device that is the target device for your code and testing it right there. Okay, so here's the equivalence test targeting a Jetson board, an NVIDIA Jetson board. Notice that I'm highlighting the differences right here. Of course, the names are different. I'm using a test tag here, the PIL test tag. Now you know where it came from. But what I wanted to bring to your attention is these two lines of code. This is the equivalence test for testing the C library locally. But notice that for the PIL or processor in the loop testing, this is all that I have to do in order to tell MATLAB, you know what? My verification mode is actually PIL, and my target hardware is actually NVIDIA Jetson. That's it. Notice that I didn't do anything else to get to run these unit tests on my actual hardware, right? And connecting to an NVIDIA Jetson, it's very easy, something very easy to do with MATLAB. We have a bunch of information that we can definitely share with you after this webinar, so that you can reference back to it. But it's very, very easy, right? So that's something that you might also want to consider when it comes to equivalence testing. So lastly, I wanted to highlight a couple more things. One is the persistence of your tests. So whenever you change your code or you run a test that failed and then now is passing, the code coverage, the code quality dashboard is going to highlight that something happened with your artifacts, so that you are aware that something has changed, and then you need to update your code coverage report. Well, actually everything else. You have to update your code quality dashboard in order to see what happened. But then see the advantage of using MATLAB Test. So MATLAB is actually being kind of your co-pilot when it comes to testing, because it's telling you, hey, something's happened. Have to change this function? Want to take a look? Do you mind rerunning this unit test? So you have the peace of mind that MATLAB will also be somehow monitoring, changes in your code. So that's the one thing. And the second thing, just to close perhaps the demo part of it, is the what John also mentioned about the certification kits, right? So we do have the IEC or the cert kit. That's what we call it. Let me just show it to you right here. IEC, ISO Artifact Explorer, and then this little app right here will show you all of the cert kits that are there available for you to to show to the X or Y regulatory agencies. For example, for embedded coder, it's right here. These are all of the certificates that are pertain to that particular toolbox. The same is true with MATLAB Test. So we have a live stream that will show you a step-by-step process by which you can certify MATLAB Test. So all of this information is there available for you, because we want to make it easy for you to use our tools, not to be concerned about how do you actually certify MATLAB Test, because we have already been we have already gone through that pain, but it's more about you focusing on how to, make or certify the function that you are working on. So this is all I have to show about this, seemingly easy to use app. So we saw how cumbersome it could get very quickly, and how MATLAB Test can make our life very, very easy when we are very structured when it comes to, linking requirements to your code and to your unit test, using a class-based unit testing approach that that will give you full access to the MATLAB unit testing framework, and of course using MATLAB Test as your command center, along with the code query dashboard for you to keep track of everything just in one place. So with that, I'm going to pass it on to you, John, and then we can conclude this demo part.
Sure thing. Let me share my screen here. All right. So thank you very much, Oscar. That was pretty interesting stuff. One of the questions that came in while I'm working towards the summary is this demo available to customers?
We can make it available to customers, absolutely.
Okay, fantastic. Thank you. So let me summarize here. So we showed you a lot of things, and obviously a lot of what we showed today is features around MATLAB Test, which is a new toolbox that came out in 23A, so just recently. But it's not all that we offer. If you look at sort of everything it takes to make high quality production ready MATLAB code, there's a lot, right? There's all the test capabilities, our test framework, mocking framework, performance framework, requirements management, traceability with requirements toolbox, this new MATLAB Test product itself that just came out. There's build capabilities to have consistent, repeatable build processes, and the ability to do equivalence testing between the MATLAB code and the generated code. There's all kinds of automation capabilities for continuous integration, ranging from server-based solutions such as Jenkins to cloud-based solutions such as GitHub Actions. There's the support of artifacts and certification with our certification kit. There's also lots of support from training and consulting. So when you take a look at the entire ecosystem of what we can support, we can provide the capabilities needed to get you from where you are today through to IEC 62304 certification. Specifically, some next steps you could take. So in terms of getting started, there is effectively a ton of on-ramps, examples, and videos. There you can sign up for a guided evaluation. There's a lunch and learn, which is, does your code pass the test, which is the basics of testing. How do I create a unit test to begin with? And what does that even look like? There's getting advanced. So there's training, lots of training capabilities, online and in person. One of the new training classes that is being developed is a requirements-driven training with MATLAB. It's not quite available yet, but will be very, very soon. And there's the accelerated aspects, which is using consulting to help you get through to certification. And they have a lot of experience in medical. We have a couple of guys that specialize just in medical. As well, we have specialists in other domains as well too. So lots of capabilities to get you up and get you going with MATLAB. Now, I want to actually, before I transition to that last slide, I want to pause for some questions. And let me see if I can pull up my chat window, which I'm not seeing right now. Oscar, one question. Where do I need to use MCDC coverage? We noticed you talk about it, but where is it required?
That's a great question, John. So whenever you have an if-then statement which has multiple conditions there, that's the best place for you to think about MCDC coverage metrics, right? So for example, you have if a condition is met and another condition is met, or another condition is not met, then do something. So this is where MCDC becomes the most useful code coverage metric.
And one other one here. Can I develop and run unit tests for GUI-based applications?
Oh, great question, John. So yes, you can. Actually, we have what we call the app designer testing framework. So you can actually test, unit test your MATLAB application. So you guys saw that I showed the MATLAB app, that I focused on the algorithms that run under the hood. But you can actually tell MATLAB to test the actual GUI of that app, right? So there are some constructs, some verifications. There is a tutorial in the documentation. I can share that with you all. I'm going to take note of that. That explains you how to do app-based testing, and it's actually fun to see because your cursor is going to go places. I'm going to simulate clicks, and it's going to show you what happens and so forth. But of course, this comes with a little bit of a toll on the performance side, because now you have to put the time to sit down and wait until these tests happen. And depending on your specific application, how computationally heavy it is, it takes some time for this test to run.
And I think we have time for one or two more. So is MATLAB Test available only for project-based applications?
It is, and I would actually recommend you guys, if you are working with many functions, many artifacts, to use MATLAB projects. It's the best way to organize your code. It's an agnostic, structure of your code that you can use no matter which MATLAB or which computer are you using or working on, because you will always get the same structure very consistently. Not only that, but also MATLAB. I don't know if you noticed, or I can share it very quickly. Let me do that. Just 1 second. But John, you're sharing your screen. Never mind. So MATLAB can actually connect with your Git repository, so that your code stays up to date all the time. So you connect your code with your source code, with your Git repo, so that everything stays up to date directly by using MATLAB projects. So absolutely recommended, not only for MATLAB tests, but to manage your projects overall.
Great points. Thank you so much, Oscar.
My pleasure.
Okay, so I'm going to wrap up here. So I want to make sure you're aware of some upcoming medical device webinars that are coming up on October 18th. There's MATLAB and Python working together, November 15th, developing real-time interoperable ultrasound. And on December 13th, leveraging model-based design for medical device development. If you scan that QR code, or you can go to our website and you can see the events on the events section of our website. You will see all of this information posted. So please take the opportunity to sign up for additional webinars. I hope that you found this webinar to be useful. If we did not get to answer all of your questions, we will do so afterwards. And as mentioned previously, there will be a link sent to you with a recording of this webinar, so you'll be able to see it again if you're so interested. Contact your account managers if you're interested in following up more and understanding more and learning more about MATLAB Test, and they can talk to you about how to get started and how to bring in experts such as Oscar to really help you get going on things. With that, we're at the top of the hour. I'd like to thank you very much for attending our session, and have a wonderful day.
Thank you, everyone.